Assalamualaikum and hi. We are students of Diploma Microbiology at UiTM Kuala Pilah, Negeri Sembilan. In this video, we are gonna talk about alkane. If you are wondering what alkane is, let's see the first part of this video. Alkane is an organic compound that consists of hydrogen atoms and carbon atoms, which known as hydrocarbons. Alkane has its own general formula, which is CnH2n plus 2, where N equals to 1, 2, 3, and so on. Alkane contains a single covalent bond, which makes it as a saturated hydrocarbon because it contains the maximum number of hydrogen atoms that can bond with the number of carbon atoms present. Alkane can be assumed as sp3 hybridized because it is formed by 4 hybrid orbitals that oriented at 109.5-degree angles to each other. It is composed of 1 s orbital and 3 p orbitals. Next is about cycloalkane. Cycloalkane has the general formula of CnH2n. It is a continuous carbon chain of alkane where the C atom join together to form a ring, and it is a saturated hydrocarbon. This is the IUPAC nomenclature of alkene. IUPAC nomenclature is the international standard of naming an organic compound to give each structure a unique name. For every organic compound, we use the same prefix for the first syllable like met, ed, prop, but, pent, hex, and more. The only things that will differentiate their functional group is the last syllable of the name. The second part is about how to name an alkene. First step is to find the parent structure. In order to find the parent structure, we have to look for the longest continuous carbon chain. If there are two chains with the same number of carbons, choose the chain that has more branch points. Branch is a substituent like the one in the red circle. Second step is, we need to number the carbons in the parent chain by starting from the end that is the nearest to the first branch point. If branching occurs to have the equal distance from both ends, begin the numbering at the end that is the nearest to the second branch point. Next, we have to identify the number of substituents. The substituents need to be arranged in an alphabetical order like shown in the picture. Organic compounds should be named in a single word, so we use the hyphen to separate the prefix and commas to separate the numbers. For two or more identical substituents, we use multipliers like di, tri, and tetra in front of the substituents. These prefixes are not included in the alphabetical ordering. Alkanes have many substituents like in the pictures. All these names are used only when they occur as a branch of a parent chain. For example, this structure is named as 3-bromo-2-nitropentane. Cycloalkane is named as the same as an alkene, which we need to find the parent structure first. For a ring alkane to become a parent chain, the number of carbon atoms must be more than their substituents. For this structure, the triangle-shaped ring couldn't be the parent chain as it has only 3 carbon atoms, which is less than the substituents that has 5 carbon atoms. But for this structure, the ring alkane will be the parent chain because it has more carbon atoms than its substituents. Then just number the substituents and write the name just like naming an alkane. Next part is isomer. Isomers are molecules with the same molecular formula but have different atomic arrangement in space or different structural formula. This excludes any different arrangements that is caused by the molecule rotating as a whole or rotating around specific bonds. If there is no carbon in alkane is bonded to more than 2 other carbons, it is called a linear chain. A branch chain is formed when a carbon is bonded to more than 2 other carbons. Chain isomerism exists because of the possibility of branching in carbon chains. These isomers are different in the carbon skeleton. They possess the same functional group and to the same homologous series. Due to that, chain isomerism has similar chemical properties but has different physical properties. For example, butane has 2 isomers with same molecular formula C4H10. One of them forms a straight chain, whereas the other one is a branch which is called as isobutane. Isobutane is the smallest branch alkane. Position isomers are compounds that have the same number and type of atoms but different bonding arrangements between the atoms. They have the same carbon skeleton and belong to the same homologous series but different position of the functional group. Since they have the same functional group, they have the same chemical properties but different physical properties. Examples for these isomers are butane and 2-methylpropane. The atoms are connected differently in the two structures because the carbon chain in butane is straight, whereas it is branched in 2-methylpropane. As can be seen from the table, it is about number of theoretically possible structures of formula CnH2n plus 2 up to N10, which we can conclude that the number of position isomers possible for a given formula is rapidly increases with the increasing number of carbon atoms. Next is about properties of alkanes. In alkanes, there are CH bonds that have only weak dipole moment. Alkane is considered as a non-polar molecule, which means that there is no charge at the end of the molecule. This causes it to be soluble in non-polar solvents but insoluble in water. Alkane is less dense than water, where the densities of water is 1.0 gram per milliliters, whereas alkane is only 0.7 gram per milliliters. If water is combined with alkane, two layers will be formed, which the top layer is alkane and water at the bottom. Boiling points of alkane depends on two things. The first is the effect of relative molecular mass on boiling points of alkene. A larger alkane, which has more carbon atoms and bigger relative molecular mass, will boil at a higher temperature. This is due to the greater surface area and greater van der Waals attractions. Second is the effect of branching on boiling points of alkane, where a branched chain alkane boils at lower temperature than a straight chain alkane with the same number of carbon atoms. So, the more branches occur in a chain, the lower the boiling points. For example, pentane boils at higher temperature than isopentane and neopentane because pentane is a straight chain while the other two are branched chain, but neopentane boils at lower temperature than isopentane since it has more branches. Melting points of alkane also depends on its relative molecular mass and branching. For the effect of relative molecular mass, a larger alkane molecule will melt at a higher temperature. It is the same as boiling points, where it happens due to the greater surface area and greater van der Waals attractions. Then, alkane with an even number of carbon atoms will melt at a higher temperature than alkane with odd number of carbon atoms, since even number of carbon atoms pack better in a solid structure than alkane with odd number of carbon atoms. For the effect of branching on melting points of alkane, a branched chain alkane has a higher boiling points compared to a straight chain alkane. Alkane's reaction involve only two reactions, which is combustion and halogenation. In combustion, alkanes are burned in a plentiful supply of oxygen to produce water and carbon dioxide. This is the general equation for combustion of alkanes. For example, propane reacts with 5 molecules of oxygen will produce 3 molecules of carbon dioxide and 4 water molecules. In a limited air supply, combustion of alkane will produce carbon monoxide and water. But in a very limited air supply, the combustion of alkane will produce carbon as one of the product together with water. Next reaction is free radical substitution that is also called as halogenation. Halogenation of alkane happens when the hydrogen atoms in alkane are successfully replaced by halogen atom like chlorine or bromine if the mixture of alkane and halogen is heated at high temperature between 300 to 400 degrees Celsius. This halogenated alkane is produced by irradiated with ultraviolet light. This is the example of halogenation. The number 1 shows the excessive methane reacts with limited supply of chlorine and produce a major product, which is chloromethane CH3Cl. The number 2 shows the excessive chlorine reacts with methane. Major product that has been produced is tetrachloromethane CCl4. Alkanes are important raw materials in the chemical industry as well as the primary component of gasoline and lubricating oils. For example, petroleum with natural gas is widely used in manufacture of plastics and detergents, while butane is used as the gas for the camping stove. Then, pentane is used as a foaming agent in the preparation of phenolic resins and polystyrene. Hexane and heptane is used for fast drying of lacquers and glues. And lastly, octane is one of the compounds used in petrol. That is all about alkane. Thank you for watching.